Hello and good evening. Don't mind the wind. I didn't know it was this windy out here, but I had to come and tell you this little story. So I was working on writing to my future self, like I like to do every year. And so I got my letter from last year, and one of the things that I passed along from the year before was like, oh, this calculation that I did on the actual size of the observable universe. I was reading this book on cosmology. Ooh. Hello, mister. Oh, look at you. Just chowing into it. Pretty. So yeah, it was just like shot here. So I was looking at that, and yeah, it is windy, buddy. Man, you're so orange. What kind of creature, what manner of creature are you? Look at those lips. All right, anyway. Anyway, so at the time I had been reading this book on cosmology and getting all excited about like the I don't remember the exact terms, but like the effective event horizon, like observable event horizon, where like we can see stuff that's like 46 billion light years away, because the early expansion of the universe was let's see, first it was super rapid, and then it slowed down, and then it sped up, and now it's slowing down again. Something like that. But anyway, so the actual event horizon is something like 46 billion light years to the end of what you could see, but the event horizon, due to today's expansion rate, is more like 14 to 16 billion light years. So anyway, at the time though, I was trying to run the numbers, and I somehow got this number of like 1.4 billion light years would be like, if you were 1.4 billion light years today and you sent a photon back to Earth, then it would be like right on the event horizon. And I was all like, oh, this is great. So anyway, I threw it in my letter to myself, and so that just popped back up, and I'm like, this can't be right? Like, surely this is not correct. So I was trying to find the calculation where I actually did it, and I finally tracked it down, found the old note, and I was looking through it. I'm like, okay, I got this from that, and as a side note, I will say it's very cool to just be rocking with units, because like if you take the Hubble expansion rate, which is the rate that the universe is expanding, I think it's typically in kilometers per second per megaparsec. So that means like how many kilometers are added per megaparsec, and a megaparsec is like 1.3 million light years or something like that. So it's pretty substantial to only be getting 73 kilometers per second now, and then the speed of light is what, 300 million meters per second, or 3 million kilometers a second. That was my mind being blown by my horrible calculations. It should be 300,000 kilometers per second, sir, not 3 million. That's beside the point. Oh, this is a great video. My goodness. Needed a wind hat, not a sun hat. My glasses aren't on great. Anyway, so the units of that are obviously distance divided by time, and then another distance. So just converting those into light years per light year, and getting a expansion rate that you can then be like, okay, what is the speed of light, and how, like, in the distance that light travels in a year, how much has that space expanded in that same amount of time? Basically, that was my technique. Anyway, this is nothing, but it was fun. And so I was going back through that calculation, and it was a mess. Yeah, just a mess. But going through step by step, and one of the numbers I had in there was like 6,300 and something. And then I ran the calculator on that, and I was like, I'm getting 630. Where did I get 6,000? And then, yeah, sure enough, I go through the rest of the calculation, and I get the correct number that the event horizon is about 14 billion light years out. But then that just completely opened up the question again that I had back then, that I think I was trying to answer, but I didn't know how to ask it, and I still didn't know how to ask it, but I did a pretty good job this time, right? So the question is, if at around 14 billion light years away, the expansion of the universe is such that you're basically adding, like, let's say, like 1 light year of distance for every year that passes. So if a photon leaves a star 14 billion light years away, after a year, it's going to have traveled a light year, but there's going to be another light year that has to travel on the way, so it would never make it to us, right? So the idea is that actually the distance that something can be away from us now and actually have its information reach us is going to need to be substantially less than 14 billion light years in order to make it to us in, let's say, 14 billion years. That's my ruler, is if something can't reach us by 28 billion years, the year 28 billion, then it's out. Like, anything beyond that, screw that. That's who's gonna be around then. So I was rocking this calculation for like an hour, trying to like make this stinking equation, and it was actually some good practice. That's mostly why I was doing it. Like, I gotta do this, right? I really gotta get in there and practice this. So I was actually doing pretty good, I gotta say. And then I got to the end of it, and I was like, well, the rate of change of the distance that's left to travel should approach the speed of light as the photon gets closer and closer to the Earth. So therefore, I'm just going to set that equal to c. So now I've got 2c divided by blah, blah, blah. Anyway, I ended up with 10 billion light years. And at that point, I'm like, okay, well, that's at least a number that I feel like it's got to be kind of close, right? So with these storming winds, I just wanted like a nice chill conversation about physics, man. Cosmology. Almost saw a beetle. Anyway, so I got 10 billion light years, and I'm like, all right, that's good enough. I'm going to call it on that for now. And at this point, this is when I cheated and just, I went and asked ChatGPT. I took a picture of my note, my calculations and equations, and I submitted it for review. I was like, can you tell me what I have done here and where I went wrong? And I feel like my number, 10 billion light years, is a little too big, and I did a quick estimate to be like a ballpark estimate, a proof of concept estimate, by being like, well, photon travels from 10 billion light years to 5 billion light years. At that point, the expansion is going to be around 2/3 the speed of light, so it should be adding another like 3.4 billion light years onto the travel time, and then from 5 billion light years away to 0, it's going to be an expansion rate of around like 1/3 the speed of light, so it should add another like 1.4 billion light years. And so already we're seeing like closer to 15 billion light years of total distance, and we only had 14 billion years to travel it, so that photon could therefore not even reach us. So I knew 10 billion was probably too big, but I felt okay about it. Anyway, ChatGPT gets in there and it's just like, looks at what I have sent it, and it just goes like, no, this is wrong. What have you done here? And it just, it starts laying into me on just like, you can't set the Hubble constant to be constant. It changes over time. Like, that is not accurate at all. And just like, you should have used proper time and co-moving distance and blah, blah, blah. And I'm like, okay, yeah. But can you just take it as an assumption, take it as a given right now, or just whatever, that the speed of light, that the expansion is not going to change for 14 billion years, all right? Let's just say that it's not changing. Now, can you evaluate my thing again? And so I'm just like trying to get an answer out of this. And there's, I don't know when ChatGPT just turned into just like this big old like, ho ho ho, I'm Mr. Science Man over here. I hold the secrets to the, it acts like it is the one that derived all of these things, and just like, it's infuriating. So it's over there just judging me for my way of doing this. In your toy model here, I guess we can do that. So anyway, the thing that I wanted to say though is, finally I got ChatGPT to actually like look at it, and then it was like, oh, well, you did the equation wrong, and it should have been like this. And so it was giving me such a hard time, and I'm finally just like, I told it to just give me hints and stuff, but by the end of it, it ended up spitting out the actual equation that I needed to use. And I was like, okay, I could put the numbers in there, but like now I feel like I'm just a calculator. You're supposed to be the calculator here. I was supposed to be doing the creative thinking part, so screw it. You tell me, using my toy model. My goodness. What is going on out here? We gotta get under shelter. My gosh. We found a little hidey hole in here. Very nice. Anyway, so yeah, gave me a hard time, and yeah, I was like, I'm not gonna just put the numbers in. You put the numbers in and you tell me what it equals, right? So let's say we keep the Hubble constant at what it is today. How far away could something be for the light to reach us by the year 28 billion? and it comes back with 9.1, something like that, 9.1 billion light years away. And I was like, you dirtbag have been giving me such a hard time. I'm like, my number was not actually that far off, and I even called it that it was too high. So like, I mean, obviously my goal was to actually get an equation that would work, so yeah, okay, fair, but also, like, come on. You don't have to be such a dirtbag about it, right? And then after the end of giving me that number, it's like, would you like me to tell you, like, the actual number if you use the modern ACDM theory? And then in parentheses, it's drastically different or something like that. Or it varies drastically or something. And I'm like, all right. First I gloated. I'm like, I was actually close. So all that stuff you said, blah, 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 I was pretty close. And then I was like, okay, fine. Tell me what the actual number would be. And it runs a calculation and it comes back with 10.5 to 11 billion light years away. And I'm like, whoop whoop. AI police does not vary drastically. That's like very not different to the actual, like, to 9 billion light years or whatever. And also, I was in an argument with it yesterday because I'm like, okay, so I've read that the expansion of the universe is not just, the universe isn't just expanding, but the expansion is accelerating. And I was like, yeah, that's true. And then I was talking about the numbers, and then, 73 kilometers per second per megaparsec today, and then in, like, 14 billion years, it's going to be like 50 something kilometers per megaparsec per second. I'm like, that is not accelerating, that's decelerating. And then it's over there making arguments. I'm like, well, I guess this isn't maybe just it making arguments. I don't know if this is something in cosmology. If you're a cosmologist, can you explain to me why we would say that the expansion is accelerating? Because the best I got from ChatGPT was that basically there's just more space, and so it's an exponential expansion, because as something expands, and that thing itself is the base on which the expansion is occurring, and the expansion expands faster and faster, but actually it's not. The actual expansion, if you take it like two stars a set distance apart from each other, the numbers aren't accelerating. Like 70 is bigger than 50, and so that doesn't seem to be an accelerated expansion or whatever. Anyway, so that was my little ChatGPT adventure here today, and the moral of the story is, when you get an amazing result in your theoretical thinking about the universe, always double check it, because probably the edge of the universe isn't 1.4 billion light years away. It's probably more than that. So always double check it. Anyway, that's enough of this one.